All right, in this introduction video, we're starting Unit 5. Before we actually get to our first day's lesson, day 5.1, we need to review some concepts that are going to be important and as we move forward with our Unit 5, where we're talking about right triangles and what we call trigonometry. We'll get to that later in the unit. But for this first short video, we're going to do a review of radicals or square roots. When we talk about radicals, we're just referring to the square root of something, okay? That's all radicals are, square roots. And so first we want to talk about the concept of what a perfect square is. A perfect square is a number. We're talking about a list of numbers. So a perfect square is a number whose square root, and square roots, remember, are those symbols, whose square root is a whole number, or another way of saying that would be, instead of whole number, we could say positive integer, or counting number even, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, those kind of numbers, no fractions, no decimals. Okay, and these include, and you probably will recognize these numbers, the pattern of these numbers. The perfect squares start with 1 because the square root of 1 is 1. Then the next perfect square is 4 because it's the next square rooted integer giving you 2. So the perfect square is 4. And then 9, which is 3 squared. So the square root of 9 would be 3. 4 squared is 16. 5 squared is 25. 6 squared is 36, so on and so forth. So I'm just going to write out the list of these perfect squares and kind of explain what we do to get those. 7 squared would be 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144, and the list keeps on going. But for right now, for our purposes of making a shorter list here, those are the first 12 perfect squares. The square root of each one of these would be the list of numbers from 1 to 12. Okay, the square root of 144 is 12. The square root of 121 is 11, so on and so forth back down the line. So when we simplify radicals, if I ask you to write something in simplest radical form, I'm asking you to break the number under that square root down into its smallest possible number that is not a perfect square. I want to factor out any perfect square factor of that number. So first thing you want to do is check the radical, check the square root to see if it already is a perfect square, to see if that number underneath the square root is a perfect square. If it is, take the square root of that and then you're done. Okay, and that's actually like example A. 64 is a perfect square. It is our 8th perfect square. So since it's a perfect square, the square root of 64 equals 8 because 64 is 8 squared. So if I take the square root to cancel out that squared, it leaves me with just an 8. Okay. However, we're going to get into other numbers that are not perfect squares. The number 20, in example B, is not a perfect square. So we need to move on to this process. If it's not a perfect square, we're going to determine if there are any perfect squares that can be divided into that radical, meaning we're checking for factors. What I like to do is make a factor tree, which you guys might have done before. And then we're going to factor out those perfect square radicals, take the square root of that part, keep the rest under the radical. Okay. All right. So the number 20 is not a perfect square. And so we'll kind of show you an example here. But I can split this. Now, because it's under a square root, I can either split it as one long square root like that, and I can split the number 20 into the product of two other numbers underneath it, or I can split it into two separate square roots multiplied together. And so what I want to do is find the biggest perfect square from my list up here. Okay, my biggest perfect square from my list, that's not the line I want. Let's fix that, sorry. Biggest perfect square from that list that I can evenly divide 20 by. Okay, I look at 1, obviously that's not going to ever help me. So we really don't ever consider the 1. We start after the 1, okay? 4, I can divide 20 by 4, but I can't divide it by 9. I can't divide it by 16. And then I'm already bigger than that with 25. So the biggest perfect square I can divide 20 by is 4. So I'm going to write that one first. And then when I divide 20 by that 4, I am left with 5 as the other factor. So what we're doing is we're doing a factor tree, but with square roots. I'm rewriting 20 as the product of 4 times 5 so that I can take the square root of that term there, or that factor. And we know the square root of 4 is 2, okay, because you're asking what multiplies by itself to equal 4. That's the number 2. And so I am left with 2 times the square root of 5, and we can kind of squish those back together and simply write it as 2 root 5, or 2 radical 5 is how we would read that. Okay? And so we'll get some more examples like this as we go through our lessons. But what we want to do now is take a look at when we are working with numbers here in example C, where there's another number outside of the square root. Well, that's like having an extra number out front that's just going to stay there until you get other factors outside of the square root. So we're just going to keep this 3. It's going to slide down here. And then I'm going to split the square root of 50 into the square root of its biggest perfect square factor times, these are all multiplied, what's left after I divide by that biggest perfect square factor. So I'm going to go through my list. Now there's certain numbers you need to start checking for. First of all, we very rarely want to divide by 10 because 10 is not a perfect square. It's not on my list of perfect squares. It's wedged right in here between the 9 and the 16. So I want to keep going up that list until I find the biggest number you can divide 50 by. Well, you should recognize that is the number 25. So if I divide 50 by 25, I'm going to write the 25 there. 50 divided by 25 leaves us with 2. And 2 is a prime number. We've already simplified that down as far as it can go. Now I can simplify this part. The square root of 25 is 5. Everything else drops down, and I see if there's anything else I can simplify. Well, the two numbers that are outside the radical now can be multiplied back together, 3 times 5. So I'm going to multiply those together and get 15, and I'm going to bring down the radical 2, or square root of 2, at the end. We always put our square root factor that's left over at the very end. Okay? We also want to talk about how to multiply and divide radical expressions. So if we're multiplying, all you have to do is multiply the radicals by the radicals and the constants or coefficients, the numbers outside of that, by their matching numbers. We don't want to mix them, okay? So since on part A, both the 5 and the 2 are both radical expressions, they're both underneath a square root, we can multiply those together under the same square root. So it's like I'm doing this. Now you're going to get to where you don't need to write it out that way. We can simply write it as the square root of 10. And then we would want to simplify that if we could, all right? But we can't here because 10 is not a perfect square and it can't be divided by any perfect squares other than 1. So that's already in simplest form, okay? So as we go through dividing again here, we're going to do root 6 times root 3. I can put those together under the same radical. 6 times 3 is 18. Now, 18 is not a perfect square if you go back up and look at your list, but it can be divided by a perfect square. It can be divided by this 9 here. So I'm going to split that. Where I couldn't do that on the last one, I can do that on this one. Instead of splitting it back into the 6 and the 3, because neither of those are perfect squares, I'm going to split the 18 into 9 times 2. 18 divided by 9 is 2. The square root of 9 goes first because that's my perfect square, and I can take the square root of 9 and get 3. And then I'm left with a 2 underneath. Notice when you take the square root going from here to here, we no longer write the square root there. I don't keep the square root symbol over the 3. It'd be like keeping a plus sign after you added 2 numbers. We don't do that. Okay, but that is your final answer there. And then we've got another example here. On part C, there are 2 numbers that are not radicals. Okay, these numbers are outside the radical. They can go together. 5 times 2 becomes 10 out front. But this square root of 27 can still be split. 27 is not a perfect square, but it does have factors that are perfect squares, or that would be a perfect square. So I'm going to keep the 10, and I'm going to split 27 into 2 factors. The biggest perfect square you can divide 27 by, hopefully you know your multiples, that's 9 again. 27 divided by 9 is 3. So when I go back down here to split up 27, the 9 goes first because it's the perfect square, followed by the square root of 3. We're multiplying all these through. So I'm going to keep the 10, but the square root of 9 is just 3. And then I keep the square root of 3 at the end. 10 times 3 here at the beginning combines to equal 30, and I keep my square root of 3. So that would be my answer in simplest radical form. Okay? Now, dividing, okay, it follows a lot of the same rules as multiplication. We are going to still keep the numbers that are under a radical together and the numbers that are not under a radical together, okay, or the numbers under the square root together and the numbers not under a square root together, but we're just simplifying by dividing. Okay, so if I've got two numbers here, like root 14 over square root of 2, you can think of that as both those being underneath the same square root, like that. There's a rule for simplifying radicals or a rule for dividing radicals that allows you to put them underneath one big square root like that. Very much how we did with multiplication. Okay, and then we just divide. 14 divided by 2 is 7. So numbers that are alike can be divided. Okay, they're both alike because they're both underneath a square root. Okay, for part B here, it's like we're going to split this into two parts. We've got the number part that we're just going to reduce. Now I'm dividing, yes, I am doing 2 divided by 4, but I don't want to write that as a decimal. I don't want to do 2 divided by 4 in a calculator and get a decimal. I want to reduce that fraction. So 2 and 4 can both be divided by 2. So if I divide this one by 2, I'm left with a 1. Divide this one by 2, I'm left with a 2. So as I'm writing my fraction, I still have a 1 times something on top and a 2 times something on the bottom. Now, for these radical parts, it's kind of like we're doing one big fraction of 6 divided by 3 underneath the same radical. Well, we can do that. 6 divided by 3 is 2. So I've got a 1 over a 2, and then the square root of just 2. Now be careful where this goes. Square root of 2, in my original fraction here, the big number was on top, so you need to think of this as being on top of this fraction. So it's like the square root of 2 over 2, or divided by 2, and that's as far as I can simplify that. Because the top number is a square root and the bottom number is not, I cannot change that any more than it is. All right, one more example here. When I do 3 times the square root of 12 on top and 6 times the square root of 3 on bottom, we can again kind of treat this like two separate pieces by splitting it. The 3 and the 6 can both reduce by a factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And then here again on our square roots, think of that as the square root of 12 divided by 3, which is 4. So that's a square root of 4 here. So I had 1 on top times the square root of 4. That goes on top since the big number was on top, over just 2. But this time I can keep going. I can make it square root of 4 over 2 like I did last time, but you should recognize that square root of 4 is a perfect square. 4 is a perfect square. So when I take the square root of 4, that becomes just 2. Now 2 over 2 can continue to be reduced to just the whole number 1. 2 divided by 2 is 1. Okay, so there's your review of simplifying radicals. You may have covered this in a previous course, or this might be fairly new to you. So I wanted to make sure we hit this first because we're going to use these square roots a lot in our further lessons.